getting to understand the norms and standards. And I'll highlight just a few of them here. The purpose of the norms and standards to ensure that elephant management is done in such a way that various things are achieved. Here and there you pick up statements like this: does not disrupt the ecological integrity of the ecosystems in which elephants occur. If you're an ecologist, you'll say, okay, what does that mean? Lawyers understand it perfectly. And it goes on. There's a big focus on the humane treatment of elephants. They recognize as being different to sheep and cows and those sorts of things. But here and there you get a little statement that sort of doesn't quite gel with the rest of it, like ensuring the sustainable use of hair, skin and meat and ivory products and so on, and then immediately followed by it's got to be done recognizing their sentient nature and so on. So you've got to think carefully when you start reading these sorts of things. When you come to the end of this particular section, the point number 3 reads that the norms and standards are informed by a set of principles contained in paragraph 3. So we skip to paragraph 3, and that has a heading of guiding principles, and there's a long list of them. Now, I don't propose, and for a full critique, one would need to go through each one of these principles one at a time, and every single one of them really has a problem, as Dave in particular knows, in that he's now got 2 jobs and 1 salary because he has to address all of these things. But the ones that I want to deal with today have to do with estimating the numbers of elephants that you have on your property. And there are 3 points that I want you to take away from this talk. The first one is that as ecologists, we operate in an environment where we are really, really short of fundamental ecological knowledge. We actually don't know a lot of things that we really need to know to manage the environment properly. The second thing that I want to take away is that because of that lack of knowledge, almost every management system that you can think of, from governments through to national parks, happens by ideology rather than scientific fact. Many of you will take offense at my saying so, but from national parks, everywhere else, there's more ideology that drives our management than real hard science. And I want to make that point clear as well. The other side of things has been made before, and that is that this idea of adaptive management, Pete Goodman in his talk mentioned that he hadn't seen too many examples of really good adaptive management, and I endorse that one wholeheartedly. This particular statement, if you read it carefully, says that legally, if you have an elephant on your property, you need to put measures in place to manage elephants and that are informed by the best available scientific information, and I've just said that that's not very good. And where it's insufficient, adaptive management must form the cornerstone of any management that you put in place. So this is a law that actually says you may not manage elephants without adaptive management. Now, again, if you think back to Pete's talk and on the requirements for adaptive management, we all know that everybody's short of money. A lot of elephants are owned by private landowners who really don't want to put 1 cent into their profit-making machines that isn't going to result in a return. So actually getting people to do this kind of thing is very nearly impossible. Same sort of statement. Wherever practical, must be based on scientific knowledge, but then funny little things like, management experience. Woo. Not too sure I want to base my management on some guy's management experience. Some of it I've seen. But again, the emphasis on sound scientific knowledge. Point M. They must be managed in the context of an objective-based management system. Now, again, I emphasize the fact that this is a legal document and you can be sent to jail if you don't do it, in theory. When we we go on in the document a little bit further, we come to the requirement for management plans. And right down, if you read through the section, don't bother with that, when you come right down to what the management plan should look like, there's a little statement that says it must follow the requirements in Annexure 1, which means that if you write a management plan for elephants, it must follow each of the points mentioned in Annexure 1. And if you go to Annexure 1, there are all sorts of things like a section on general information, and this goes on for on the understanding that most of the areas with elephants have very vague, very confused objectives. You've got a double problem in that you now have to relate this preferred density, which is a kind of a wishy-washy thing, to wishy-washy objectives. So hard science is now becoming really difficult to do. So if we go back to the history of methods for determining stocking rates, and I don't really have time to go through a lot of the problems with it all. Historically, what happened is that the Department of Agriculture produced maps that they called maps of carrying capacity. What they were was preferred stocking densities for cows. And you could get a map of South Africa that had carrying capacities on it for particular regions. Gee, sorry, my mouth is drying out. Dinner was a bit much last night. So these carrying capacities were used in wildlife management to determine stocking rates for different herbivores by portioning what was called large stock units, which was a kind of a metabolic equivalent of a steer to different unit of land. So if you were going to keep goats instead of cows, goats would make up a certain number of cows, and you'd work out how many impala were equivalent to cows and so on. And that was done in some instances for elephant. More recently, people have looked at things like grazing capacities and determined a particular grazing capacity based on a whole range of things like forage value and palatability and all of the rest of it. Essentially, it's not really much better than the original guess. It's a kind of a guess that looks a little bit more sophisticated because it's got some Greek symbols in the equation. And the same thing with the browsing capacity. Guys are estimating browsing capacities based on available browse, and the equivalent here, because cows don't graze, is the equivalent is a kudu. So you relate impala to, based on metabolic mass, to the number of kudu. But again, they are essentially sophisticated guesses at estimating a stocking rate. The thing that underpins all of the stocking rate estimates is actually a desired state. And if we look back through the history of this kind of thing in agriculture in particular, many of you will know of the development of increase of species and decrease of species in grazing. But the elephant situation has very, very similar thinking. There's an almost fundamental understanding that people think they have about elephants. That if you put elephants into an area, what is going to happen is that some species are going to decrease and other species will increase. And if you just bring the elephant numbers down to a reasonable sort of level, you're going to maintain the productivity of the system. And when you start looking at the ecology underpinning that, or looking for evidence for that sort of thinking, it really isn't sound. Even in the agricultural context, those of you that have done the work in grasslands will know that you put a particular number of cattle onto into your paddock, and the expectation is that species A will increase and species A decrease, and yet do it like that for 3 years. You go and look at the thing, and sometimes it works that way, sometimes it doesn't. And there's no kind of cut and dried, definite statement that says that this species is always an increase under a particular stocking rate, and because there's so many other factors that influence it. And when you deal with browsers, it's even more complicated. So this idea that you can keep the system in a desired state hasn't really got a lot of data underpinning it. In almost all instances, the reasons for putting stocking rates together is that, what am I on? The reasons for putting these stocking rates together are economic. with cattle, all of those kinds of things, the idea of keeping your system in a desired state is so that your productivity is maximized. But again, it's a kind of a false economic model. It's a generalized sort of thing that says when you've got an eruptive population, you can optimize on offtake. And if you are a good enough farmer to kind of get your offtake at maximum reproduction and at maximum stocking rate, and there are various models to find that out, then you maximize on economic returns. But the models that are used are not true economic models. They're not models that actually tell you exactly how many rands you're going to get out of the thing. So in a way, they're more aesthetic stocking rates than they are actually any kind of stocking rate that deals with currency. Now, when it comes to elephants, there are probably three things that you can do in manipulating elephant numbers that will result in some sort of change. You can change the rate of loss of trees. One elephant per square kilometre is going to have less of an effect than 10. We know that. So you can reduce the rate of loss. You can prevent the loss of a few species, maybe, under very, very particular circumstances. And you can also reduce the frequency of contact with elephants. Now, this seems like a strange thing to put in, but for many people, particularly private landowners and lodges and so on, there are real problems in having elephants around every corner. And that, in a lot of systems today where elephant numbers are increasing, is what is happening. And many, many people feel, they don't state it explicitly, but that's what drives their notion of what their preferred stocking rate is going to be. So there are three kinds of aesthetic carrying capacities that you can, stocking rates that you can look at, I think, in terms of elephants, and that's a reduction in the rate of change stocking rate, a species preservation stocking rate, and an elephant encounter stocking rate. Now, I almost guarantee that I don't know how many plans you've looked at so far, you have never seen any of those sort of things in a management plan. So if we're going to get the norms and standards to a point where we actually understand what we're doing, where science is driving it as the Act says it should, we need to then focus on this a little bit more. But then let's just look at carrying capacity. What will happen if we leave elephants alone? Carrying capacity is probably one of the most least understood aspects of ecology around at the moment. Carrying capacity happens for one organism in the area that organism can walk around in its lifetime. You will hear all over the place, historically, elephants used to wander all over Africa and they destroy trees in Soshanguve Reserve because they fenced in now, and in the past they could move all over the place. That's not how carrying capacity works. You die because you can't get food or sufficient food in the area that you move in. What is outside of an area that you can move in is of absolutely no significance at all. If you've got one water point and you can walk 10 kilometers away from that water point because of the energetics and the arrangement of food and those sort of things, what is in that circle of around 10 kilometers around that point is where your carrying capacity is determined. So the scale issue in terms of carrying capacity really doesn't have a lot of, and you know, it's a different topic of conversation in terms of the ideas that there were cycles in space where elephants used to destroy an area and then die out in that area and move to another area and cycle in space and time and all the rest of it. Those sorts of ideas also don't have any real background. And it's a fundamental question. Why would there be no elephants in one place and a whole lot of elephants in another place? We don't see it anywhere. Take Kruger National Park, it fills up with elephants. There are no spots in Kruger where you don't have elephants. So that sort of thinking really doesn't have any basis at all. So carrying capacity happens. When you run out of food, you die. That's what carrying capacity is. And it's determined by sunlight and by soil and water and the availability of food and how you get it and so on. So one of the sorts of things that we can do is, instead of estimating a stocking rate, is actually go about calculating the carrying capacity for that landscape. Having said that, there's nobody that I know of that can do it. We don't know enough about elephants to actually do that. We can't calculate carrying capacity. And I all know you're thinking, but there are all sorts of books with carrying capacities mentioned in it. It's a misuse of the term. You really don't have the ability to do that. Now, remember our requirement for adaptive management? That's the thing that the revision of the norms and standards must concentrate on much more. There's a lot that we can't do. I think we need to go ahead and put this adaptive management idea into practice, otherwise we're slaughtered. I think that's about it.
Awesome. Thanks very much. We've got 2 minutes for questions. If anyone's got any questions for Bruce. Right?
Just a comment. You know, the realities of managing in protected areas limit what we can do. And we end up having to set these, what do you call it, these preferred